Here we are again, the old CCNA4. Now we're going to talk about broadband solutions, which, I don't know, probably the most relatable. I don't know, going in depth to, I believe, DSL, cable, talk a little bit about broadband wireless, but these are actually probably some things you would actually see in the Valley, so it's kind of cool. Where it fits into the WAN, right, is we use these, but we don't want to connect our networks and have all of our stuff intercepted, so we use VPN across them. But let's jump right in. Right. So DSL, broadband, all these. One thing they can include is they can allow us to telework. So that's where we just VPN in, right, from our house, and everything is hunky-dory, and life is good because we can work from our house. Maybe not all the time, maybe on a snowy day or something, but some people just get to work all of the time. And so that's teleworking or telecommuting, and this could be not just your computer, but your phone could actually VPN in and look like you're calling from your office, and anything else. The benefits of teleworking: improved employee productivity. Debatable, probably depends on the employee, just like that always depends on the employee. Reduce costs and expenses. That's true, right? You don't have to buy a desk for them because they're just going to work at home. It reduces costs and expenses for the employee too, right? They don't have to drive there. Easier recruitment and retention. You can hire from anywhere, right? Reduced absenteeism. They're always at work because they're just working from home. Improved morale. They're happy because they're at home, I guess, instead of at work. Improved corporate citizenship. That's okay. That one we need. What is improved corporate? Allowing employees to work from home and reducing the commuting emissions. All right. So, better citizen because you're not polluting cities. You're staying at home. Kind of sounds strange, huh? Improved customer service. Oh, I guess you're super happy working at home, so you're just giving customers the best service possible. Okay. All right. Benefits. Helps reduce traffic. Oh yeah, that means rush hour. In Seattle, everybody telecommutes, right? So there's no traffic at all. Helps reduce urban drift. What is that? Urban drift refers to the movement of individuals from rural locations to city centers. Okay, so some people can stay at Grangeville when they can telecommute. Alright, great. Improve rural and suburban amenities. How about that one? More people working in rural or suburban regions could mean better mass transit service. I don't get that one, but sure. Individual benefits. Over 70% of teleworkers claim they are significantly more productive. I can actually see this. Sometimes I don't believe some of these things, but if you work from home and you're like, oh hey, I need to do this real quick, and you're used to working from home, you're just gonna fire up the old PC and get something done. So that's probably very true. Second, flexibility. Teleworkers can better manage when and where work is performed. They have more flexibility to handle many other details of modern life, like getting the car service. That makes sense. Cost savings. Employees that must commute to an office spend a significant amount of money adding up vehicle, fuel, and maintenance, lunches, work, clothes, eating out, and all other costs of traditional work that one can reduce by teleworking. Home and family. For many people, spending more time with the family or caring for dependent relatives is a major reason for teleworking. Sounds very logical. Bad things about telework. Tracking employee progress. Well, when people just dial into work, you have to monitor them a little bit better, because someone could just, you're either getting tickets down in our field or not, so I don't think this really ties into us, but I do know a database admin that often knew that as long as he just did a little bit every few minutes, he would get paid the same. But on some days, he would work very hard as well. So I could see that. Necessary to implement new management style. Well, because you're managing from afar, so that makes sense too. From the employee perspective, they feel isolated. They're sad and alone. Slower internet connections. Boo. Distractions. Okay. That sounds like stuff you're probably not going to be tested on the CCNA. But all right. So what are we showing here? Remote connections, right? And what do we have? Broadband network ISPs. Have the firewall. Okay, so we'll find out we can do different types of VPNs, but what it's showing here is the mobile worker can establish a VPN. This router with the individuals running more than just like this, I suggest like a laptop. Cisco actually makes these little home routers, or they're actually an access point. You just plug them into your internet. They fire up and they'll establish this VPN without anybody having, well, your IT department probably configures it, but then your phone and everything connects to that, so they're pretty nifty. Then you have a little bit bigger office where it is doing an SSL VPN, and then apparently that same small office, for whatever reason, is using a layer 2 VPN to the WAN, which they say frame relay, ATM, etc. Probably the most common, right, is going to be MPLS, but MPLS can do layer 2 or layer 3. But just know whenever you see layer 2 VPN, it just means it's a secure connection, like through one of these like frame relay, as we learned, right? It puts tags on. Same with ATM. You're kind of in your own little world. Same with MPLS, and so it keeps you segmented across. That's why they call it a layer 2 VPN rather than just an application VPN like IPsec. I guess that's what I consider it. But I don't know, I'm probably rambling on too much, but those guys are connecting, and then we have just our plain old broadband with this branch office as well. Alright, so this is more talking about what a VPN is, and we'll be learning a lot more about VPNs, like actually how to set them up. You're not tested on this in the CCNA route switch. This is more of a CCNA security thing, but it's good to know, and we will actually set up a generic routing tunnel or a GRI tunnel, which can be part of a VPN if we want it to be. As you can see, this is a tunnel, but it's not just any tunnel. We put encryption on here, and when we use IPsec, hopefully you guys remember, is not any one thing, but it is a suite of things, just like TCP/IP is a suite of protocols. So it's constantly changing, and so we get stuff like AES that we can encrypt with, and then we have hashings, and then it's passed with Diffie-Hellman, and then we can pick to have MD5 hashings or SHA, but it's just securing and keeping our information secure over this tunnel. And so what the tunnel actually does, and that's why it's called a VPN, is this is a public connection and this is a public connection, but inside this tunnel, these two devices think they're connected via a private network, hence the term virtual private network. And so it's basically an extra layer 3 tag whenever we say tunnel, and that's why we can say we can tunnel from IP version 4 to IP version 6 and blah blah blah, right? Anything like that, it's doing a similar fashion of what the VPN is doing. Home components, are we missing anything? We need a remote VPN router, we need some sort of internet connection, and actually we could just have a VPN software installed if we wanted to. And then it's going to hit the head end of the VPN router, which is usually an ASA. They used to be called VPN concentrators, then they were called PICs, now they're advanced security appliances, or any checkpoint is going to allow you to VPN in, or basically any firewall you can find on the market is going to have some sort of VPN capability. Alright, so now into the nitty-gritty. of our technologies. We're not. This is how cable TV works. All right, and you guys can look at that, but you're not actually tested on that. There's a little bit about these spectrums. We'll just hit the main points. Downstream, the direction of an RF signal transmission such as TV channels and data from the source or head end to the destination, or subscriber's transmission from the source to the destination is called the forward path. Downstream frequencies are the range of 50 to 860 megahertz. Upstream, so that's the electrical frequency on there. Upstream, the direction of the RF signal transmission from the subscriber to the head end. Upstream frequencies are in the range of 5 to 42 megahertz. This is also why, as we can see, these bigger ranges than these. It's probably also why we have our download is faster than our upload with cable. Anyways, so we have data over cable services, interface specifications, DOCSIS. So whenever we see DOCSIS, we think cable, and we see our little coax cable here, right? So DOCSIS specifies the OSI layer 1, layer 2 requirements. For the physical layer, or layer 1, the cable provider can use DOCSIS, specify the channel widths or bandwidths of each channel as 200 kilohertz, 400 kilohertz, 800 kilohertz, 1.6 kilohertz, 3.2 megahertz, and 6.4 megahertz. DOCSIS also specifies modulation technique, which is how to use the RF signal to convey digital data. Then we have our MAC layer, which defines a deterministic access method, time division, multiple access, or synchronous code multiple access method. SCDMA. These little things like this, I think on this test they're going to be, but you probably won't see them again. But just know that you have cable, the layer 2 is TDM, or it's SCDMA, right? What else do we need here to understand the MAC? Yeah, I don't think any other stuff. Read through it if it interests you, but you're not tested on it very much. Alright, so delivering services over a cable network requires different radio frequencies. Downstream frequencies are 50 to 860, we already said that, and upstream are 5 to 42. Two types of equipment that are required to send digital modem signals upstream and downstream on a cable system are CMTS, cable modem termination system, at the head end of the cable operator. Boom, right there, right? And then the other thing we need is this thing right here. A cable modem enables you to receive data at high speeds. Typically the cable modem attaches to a standard 10 base T Ethernet card in the computer. 10 base. Alright. Anyways, what else is it saying here? Distribution network segment feeder is from 500 to as many as 2,000 subscribers. The more subscribers you have on there, the worse it gets, right? What is DSL? Well, it's phone lines. DSL is a means of providing high-speed connections over installed copper wires. DSL is one of the key teleworker solutions available. Several years ago, Bell invented telephones. Then it made asymmetric DSL, that's the most common, right? We have symmetric DSL, which means it would have the same speeds, but typically it's ADSL, asymmetric DSL. Okay, the different varieties of DSL provide different bandwidths. Some with capabilities exceeding 40 meg. The transfer rates are dependent on the actual length of the local loop connecting the subscriber to the local office. So the farther away you are from the local loop, the slower you are, is what it's trying to say. And the type of condition of the cabling. For satisfactory ADSL service, the loop must be, here's important, this is a question you get on quite a few tests. ADSL, the loop must be less than 3.39 miles, or 5.46 kilometers. Okay, so that's the important thing about DSL. But then DSL has all this other junk too, right? So we have our DSL modem. Okay, we'll just go here. The connection is set up between a pair of modems on either end of a copper wire that extends between the customer premise equipment, CP, and the DSL access multiplexer, the DSLAM, right there. A DSLAM is the device located at the central office of the provider and concentrates connections from multiple DSL subscribers. A DSLAM is often built into an aggregation router. So then, what do we have here? I don't see a transceiver on here. Huh. Anyways, transceiver connects the computer of the teleworker to the DSL. Usually the transceiver is a DSL modem connected. Oh, there we go. Connected to the computer using USB or Ethernet cable. Newer DSL transceivers can be built into small routers with multiple 10 to 100 meg switch ports. I think you guys know that. Alright, the DSLAM is located at the CO. The DSLAM combines individual DSL connections from users into one high capacity link to an ISP. This micro filters, the reason you need those is if you're sending data across this wire, it keeps these phones from, I don't know, sounding bad, I guess. Here it is. Here, that's where it's going to talk about it. Alright, separating voice from DSL. Do we have any more cool pictures? There's our micro filters, filtering out the data from the voice. What is important? When the service provider puts an analog and ADSL on the same wire pair, ADSL signals can distort voice transmissions. For this reason, the provider splits the POTS, or plain old telephone system channel. No, public, yeah. I think it's plain old telephone system channel from the ADSL modem at the customer premise using filters or splitters. This setup guarantees uninterrupted regular phone service even if ADSL fails. When filters or splitters are in place, the user can use the phone line and the ADSL connection simultaneously without adverse effects on either service. So that's cool. Anyways, take a look at that, but that pretty much sums up what you need to know on that page. Alright, now we get our fun stuff. We have the most common types of wireless, 802.11, right? It says it supports speeds up to 7 gigs, but that's where they're including AD, so yeah, sure. So then we have 802.16, which is WiMAX, uses point-to-multipoint technology to provide wireless cellular broadband access, supports 1 gig. Then we have 4G, so 4G variations include, I don't know. Where you're going to see this would be backup links. So 3G using UTMS, CDMA 2000 Edge, or HSPT. 4G, hopefully you guys know the G's stand for generation. This is second generation technology, third generation, fourth generation. Using WiMAX or LTE. Why do they have both of these? Because LTE is a lot like WiMAX. So it just depends how it's used. I don't know. It's hard to find a difference. And then we have satellite for wireless, right, where we shoot to space. Here's a wireless mesh. So what they're actually trying to show here, and I don't think they do a very good job, as far as I am, so municipal, when we say mesh, so these are all just, these buildings would all be connected through a mesh. It's not like WiMAX, where WiMAX typically is where they're sending out signals all through here, and sometimes this wireless mesh, so one could be feeding it, but it could also be feeding, like with this cloud, it's almost like they're saying that, but it's, I wouldn't call that a wireless mesh. But anyways, these access points are connected but feeding an area of the city, right? And like Denver does that kind of stuff. And yeah, many Municipal governments often working with service providers are deploying wireless networks. Some of these networks provide high-speed internet at no cost to the providers, right? So that is what they're trying to show. They're not trying to show, a lot of times, I thought they were trying to show a bridge. Anyways, so this wireless mesh, they're just giving free wireless internet, just like LCSC campus, right? Then we have WiMAX, aimed at providing wireless data over long distances in a variety of ways, from point-to-point links to full mobile cellular type of access. Okay, so I want to make sure you guys understand. When we say point-to-point, that's what we call a wireless bridge. Why is my marker not working? Okay, here we go. So what that would be is, like, we have an access point here on a tower, and instead of running a wire, we connect this access point to this access point, and it virtualizes a wire, right? Except it's slower and more prone to interference. So that's a point-to-point, right? Where point to multi-point is where a bunch of access points connect to one, and that's where you see your internet service providers. They're usually point to multi-point radios that they put up, and then everybody fires at them. Okay. WiMAX, similar to a cell phone tower, and this is where they would be point to point, and it covers 3,000 square miles, so that's a big range. A WiMAX receiver that is connected to a USB port or built into a laptop or other wireless device. So this one's more like what I would consider LTE or something like that, but perhaps some people do ISPs like this. Anyways, and how is it powered? The WiMAX tower has something like a T3 line. It probably has fiber in this day and age, but anyhow, hopefully that covers that part. Cellular, I think you guys all know that you can get internet over your cell phones. You get 2G, 3G, which stands for generations of technology. Right now they're in the LTE, or long-term evolution, a newer and faster technology considered to be part of 4G technology. Alright, satellite, a lot slower, because you have to go to space. So you have different types. One-way multicast. Satellite internet systems are used for IP multicast-based data, audio, and video distribution. Even most of the IP protocols require two-way communications for internet content, including web pages. One-way satellite-based internet services can be used to push pages to local storage at end-user sites. Two-way interactivity is impossible. One-way terrestrial return. Satellite internet systems use traditional dial-up access to send outbound data through the modem and receive downloads from the satellite. This is very popular, I don't know, probably 10 years ago. In rural areas it was pretty popular. Two-way satellite internet sends data from remote sites via satellite to a hub, which then sends the data to the internet. Satellite dish at each location needs precise positioning to avoid interference with other satellites. Alright, so satellites known as VSAT. A company can create a private WAN using satellite communications in a very small aperture terminals, VSATs. A VSAT is a type of satellite dish similar to ones used for satellite TV. Anyways, very expensive because you gotta get that satellite to space. So it's usually the last attempt. So comparing broadband solutions. Alright, so we have cable, DSL, fiber to home, definitely the best, probably the hardest to get. Right? Requires fiber installation directly to the home. Shown in the figure, there it is, there it goes, cool. Cellular mobile coverage is often an issue even within a SOHO. Bandwidth is relatively limited, right? Because we have bandwidth cap, or We have download capped Wi-Fi mesh. Most municipals do not have mesh networks deployed. If so, available and SOHO isn't range, then is a viable option. WiMAX bitrate limited to 2 megs per second. Subscriber cell size is 1 km to 2 km, 1.25 miles. Satellite, expensive, limited, slow, often provides access where there is no other way, such as with military and government contractors. Alright, so then we have our good old friend PPP, and we kind of talked about this back in the PPP, but one thing DSL can use is if you ever have your DSL installer come and they run this stupid little instant setup, and if you don't have your DNS right, it's not going to work. Well, the reason that is it's just an easy mode for PPoE, so they just put in a phone number for all the passwords. But if they don't, then they have to do PPoE. And so remember, PPP allows authentication and that kind of thing. So this is just PPP over Ethernet, PPPoE, or PPPoE, PPP over Ethernet, like so. Right? So this is traditional PPP. This is PPP over Ethernet. And so it allows them, right? Authentication, but also remember PPP allows us to guarantee quality of service and that kind of thing. Set the link at a certain value. So ISPs value PPP because of authentication, accounting, and link management features. Customers appreciate the ease and availability of the Ethernet connection. However, Ethernet links do not natively support PPP. A solution to this was created with PPP over Ethernet, as shown allows PPP to be sent over Ethernet. Yeah! Configuring DSL connectivity. So, as I was saying before with our PPoE, just like when we did PPP between routers, and so we had to do a chat password, right? We have to put in a password and a username for PPP over Ethernet. That's basically all it's saying, and you do that inside of your DSL modem. And here they're just doing it, I guess. I've never seen this dialer thing, but apparently if you ever had to do it by actual Cisco CLI, here's how you do it. You create a dialer, you encapsulate for PPP. I guess it's going to negotiate the IP address. You set your chat host name, you set your chat password, you set your MTU. Notice this is smaller than your MTU, which we'll see this in tunneling as well. The MTU is now smaller than our normal MTU. Our normal MTU on Ethernet is 1500. We're going to make it smaller because we are adding onto this packet. We have the PPP on top of the packet now, and so I guess then we put a dialer pool. I don't know why our dialer up here is 2 when the pool down here is 1, but hey, that's how it works, I guess. Not an expert on PPP over Ethernet from CLI. Usually you do it through GUI. You just type in a password and a username, and you're good to go. Alright, if you want to try that PPP over Ethernet for no real reason, go ahead and do a show me, and there you go. Alright, so that's all. You might want to reread over like some of just the small stuff. There's a lot of tricky questions on this test just because there is a lot of really fine details that you will never be asking, but it is important for this chapter test. Anyways, if you enjoyed it, if you have any questions, please feel free to send me an email.